Let's now take this problem 45 of your textbook. This problem 45 says that a uniform rod of length L, which we have shown in the picture, rests against a smooth roller. There is a smooth roller as shown in the figure. Find the friction coefficient mu between the ground and the lower end if the minimum angle of the rod that it can make with the horizontal is theta. So this is the minimum angle theta. The point is, we have to find out the minimum friction. What is the minimum friction? Looking at the diagram, you can be very clear that there has to be a minimum friction. If the friction is less than that, then what will happen? This rod will start slipping in the backward direction, and eventually the rod will drop. So in order to stop that, there has to be a minimum friction. So now let's solve the problem. Let's first identify the forces acting on it. This height h is given, remember, and the whole length is L. If the whole length is L, then definitely from somewhere here, there is a force mg, which is dropping down, which is force mg. And the length from the end P, let us consider this point as the point P. From P to this center of mass is obviously L by 2. So we have seen that there is one force mg which is working down. Now, this roller, obviously, since it is a roller, it will apply a perpendicular force on the rod. Let this force is R1. If this force is R1, it has got two components. One component is a vertical component, which is R1 cos theta, and there is a horizontal component, which is R1 sin theta. If this angle is theta, then this angle is theta, this is theta, and this is 90 minus theta, and this is theta. It is clear? And also there is a force, vertical reaction force here, which we call it R2. If it is R2, then there is a frictional force because the rod is trying to slip towards backward. So there is a frictional force here, which is mu R2. So we have identified all the forces. Once we have identified all the forces, then I once again repeat to you, to solve this kind of problems, you have to take that object as a free body, then equate the vertical forces upward equal to downward, equate the horizontal forces leftward is equal to rightward, and then equate the torques. Anti-clockwise torque will be equal to clockwise torque, and then only the body will be in equilibrium. So we have only three things to do. These three things, then let's write it this way. Taking the free body, taking the rod as a free body, what we can do? Upward force, as I said, we have to equate vertical forces. We find upward forces R2. So R2 will be equal to R2. There is another upward force. There is another upward force. Upward force R2 plus there is another upward force R1 cos theta. R1 cos theta. This has to be equal to downward force, which is equal to mg. Clear? So let us, for your future reference, R1 was the upward force, R1 cos theta was the upward force, R2 was upward force, and mg was downward force. This is how I equated it. And when we equate the horizontal forces, R1 sine theta is backward and R1 sine theta is towards left will be equal to towards right forces mu R2. R2. So like earlier, this mu R2 is towards right, R1 sine theta is towards left. So see, only vertical and horizontal forces had been equated to maintain the equilibrium. And now we do one thing. We consider this as equation 1, relation 1. We consider this as relation 2. Fine? Then we proceed. From relation 2. From relation 2, what do we get? Mu is equal to R1 sin theta upon R2. R1 sin theta upon R2. Then from equation 1 we got, from equation 1 we have the value of R2. R2 is equal to mg minus R1 cos theta. So if you put the value of R2 here, so mu is equal to R1 sin theta divided by mg minus R1 theta. Right? We call this as relation 3. Once we have done it, now I told you at the beginning, here we have considered the vertical forces, here we have considered the horizontal forces. One more relation is left, that is balance the counterclockwise and clockwise torques. So now we consider torques. Considering torques. I also told you earlier in some case, then when you consider torque, you have to always take a pivot because you have to take torques around particular point. Now, practically, you can, theoretically, you can take that pivot anywhere. If you do it, you will find it that the result becomes sense. But practically, you should choose the pivot a little cleverly so that your numerical exercise becomes simple. Here you take the pivot around P, because if you take the pivot around P, then the force R2 goes through the pivot, force mu R2 also goes through the pivot, so they have no contribution in creating a torque. So automatically my arithmetic will become simpler. So I write considering torques around P. Considering torques around P, what happens? Considering torques around P we have to find, there is a force R1 cos theta trying to give a anti-clockwise torque. R1, sorry, not R1 cos theta, R1, this R1 multiplied by PQ. Let me consider this point as Q. R1 multiplied by PQ. PQ is a perpendicular distance from the pivot to the force R1. So here R1 PQ, R1 PQ distance will be equal to another torque is applied by mg. What is the perpendicular distance of mg from PQ? From the point P, this is the perpendicular distance. This is L upon 2 cos theta. L by 2 cos theta. So this is mg L by 2 cos theta. Now what is PQ? PQ, now we can write here. Now PQ, relation of PQ is like this. H is given. This height H. H upon PQ is equal to sine theta. Therefore, PQ is equal to H upon sine theta. So you put the value of PQ in this equation. So R1H upon sine theta is equal to mgl by 2 mgl by 2 cos theta. mgl by 2 cos theta. From here we find R1 is equal to mgl by 2h, mgl by 2h multiplied by sin theta cos theta. Sin theta multiplied by sin theta cos theta. Now we go back to this relation mu. We go back to this relation of mu. We have mu is equal to, so we write, so mu is equal to R1 sin theta upon R2. I write it once again for clarity, R1 sin theta divided by R2. Now R1 value we have got here. So this becomes mgl by 2h sin theta cos theta, that multiplied by another sin theta, and whole thing divided by R2. Whole thing divided by R2, and R2 is mg minus R1 cos theta. mg minus R1 is once again mgl by 2h, sin theta cos theta, that multiplied by another cos theta. So what do we have finally? This is the value of mu. So finally what do we have? The 2h at the bottom can get cancelled if we multiply this by 2h. Right? So this is MGL sine theta, MGL sine square theta cos theta. So we have MGL sine square theta, sine square theta cos theta. At the bottom we have 2HMG, 2HMG minus again MGL sine theta cos square theta. MGL sine theta cos square theta. Here we find mg gets cancelled everywhere. Mg gets cancelled everywhere. So result becomes L sine square theta cos theta, L sine square theta cos theta whole divided by 2h minus L sine theta cos square theta. L sine theta cos square theta. So this is mu. So this is your answer. Next we shall go to the next question.